covalent compounds is that ionic compounds conduct electricity. They're electrolytes. Now, one thing to understand is not all ionic compounds dissolve in water, but of those that do, they conduct electricity, and we can demonstrate that fairly straightforwardly with what is known as the faculty electrocution device. Basically, we've got a circuit that includes a light bulb that we're going to plug into the wall, and breaking the circuit is this beaker of water that's got nothing in it, and then you can see that we have two bare wires, and that's why it's called the faculty electrocution device. So there are, let me show you, just so you understand, there are two bare wires that are just going to poke down in the solution, and we have two equivalent circuits here, one on the left here and one on the right. So what I'm going to do is I'm going to put some compounds into the beakers and give them a stir, and then we'll plug it in and see whether or not the compounds conduct electricity. All right, so let's start with something that you're very familiar with. Here's salt, sodium chloride, and let's see if sodium chloride conducts electricity. We're going to, let's show you first that plain old water does not conduct electricity. And we can do that by so, plain old water does not conduct electricity. And now let's be bold. Let's just put the salt in, and we won't stir it or anything. And hopefully the light will come on. All right, so sodium chloride dissolves in water, dissociates to form sodium cations, chloride anions, and those anions and cations allow electricity to be conducted through this water solution. All right, so we'll come back to this one now. Unplug that so we don't forget. And let's look at another household ingredient, sugar. Okay, this white powder that looks like a bag of cocaine, except it'd be worth a lot of money if it were cocaine. And we'll just sprinkle some sugar into this beaker. First of all, we'll do the control experiment, show you that no electricity is conducted. And then, because sugar dissolves sort of slowly, I'm going to unplug it and put some sugar in and actually give it a good stir, just to be fair. Well, that's a good bit of sugar, and it's unplugged, and we'll give it a stir, and we'll plug it in. Okay, no light. Now, if you look at the graphic, you'll see the molecular structure of sugar, of sucrose, and that suggests that it is not an ionic compound. Again, it has covalent bonds, and compounds that have just covalent bonds, or molecular solids, don't conduct electricity. All right, let me clean this up, and we'll look at two more compounds. Okay. Again, plain water. Does not conduct electricity. Let's add some ethanol. Ethanol is a compound with covalent bonds. It's a liquid, so we don't even have to stir. Basically, this is grain alcohol. It's the alcohol that is in your mixed drinks. And you can see that in the graphic box, the structure of ethanol suggests that it is not an ionic compound. Again, it does not conduct electricity. It's not an electrolyte. Finally, let's look at one more household compound. Here is Drano. And the active ingredients in Drano are sodium hydroxide and sodium hypochlorite. Excuse me. And we'll add some Drano. And there we go. And if you look at the graphic, sodium hydroxide and sodium hypochlorite are both ionic compounds. When we add it to the water, they dissociate to form free ions, and those free ions conduct electricity, as evidenced by the fact that the light bulb lit up. So, to remind you, ionic compounds, if they dissolve in water, conduct electricity. Now, not all ionic compounds dissolve, and you have to learn which ones do dissolve, but compounds that have only covalent bonds do not dissolve in water to give ionic solutions. They may dissolve in water. For instance, sugar dissolves in water and ethanol dissolves in water, but because they do not give ions, the solutions do not conduct electricity.